video. So this is video part 2. I said there wasn't going to be a part 2, but it turns out I decided to make a part 2. Why? Well, if we look at the building, let's figure out how we calculate power for the empty spaces. Future tenant at 1,200 square feet. Let's use that number. We don't know anything. We don't know what's going to be in there, how many offices, how many water heaters, how many bathrooms, how many air conditioning units. We don't know anything. So there's some allowances. We can get an educated guess. We know office use a certain amount of watts per square foot. When restaurants and other things use a different number, higher number. We're going to assume all these are offices. So that will be panel 2, panel 3, and panel 4. Let's go to the spreadsheet. So we don't know if there's going to be an air handler 1, a heat pump 1, air handler 2, heat pump 2, air handler 3, heat pump 3, water heater 1, or water heater 2. So we're going to delete that. They're all zeros as far as we know right now. There's no kitchen, no bar that we know of. And the square footage is 1,200 square feet. Where are we? So here, 1,200 square feet, each one of the spaces. And I'm calculating all three at the same time because they're identical. So over here, panel P2, P3, and P4, they're identical. So how do we come up with a number? Well, we can give ourselves an allowance of 25 watts per square foot, because more or less every office will use 25 watts per square foot, more or less. The power company calculated that, so there's a list. You can get that list somewhere. What it says here is 1,200 square feet times 25 gives us a number, plus 1,200 gives us that number. So we're adding across. We add a 0 plus 0 plus 0 plus all the way across. So 30,000 plus 1,200, that's 31,200. We are sticking with 3-phase because we got to maintain the same phase. If we bring power at 3-phase to one space, we got to bring them all the same phase. What happens here is it says here we need 108 amps. If I wasn't worried about if I knew that it was going to be less than an office, I would do my best to get that under 108, and I would play around with that until I could make it work. If I'm running it at 24 and that don't work, so I'm going to cut it to 22, and there we go. So maybe 23 would work, and that's not the end of the world. I want to give this a little fat actually, and instead of trying to squeeze 100 amps in there, I'm going to leave it as it is, and I'm going to say the size for that electrical panel is going to be a 200 amp panel. So I'm going to put 200 amps in there, a 200 amp panel, and I have a little latitude. Now, if they decide to put a restaurant, then it's going to need more than 200. But since we didn't know that in advance, they're going to have to maneuver that themselves. They could have told us in advance, hey, look, we plan on making this a restaurant, but they're not going to do that. Chances are they're not going to put a restaurant there or some sort of place that uses a lot of electricity. Okay, so that was panel 2, 3, and 4. Let's do panel 5, which is for the separate building 2 of what do we call it? Specialty flooring. We know there's one air handler, one heat pump, and if we remember from the earlier video, it uses the same amount of watts. The air handler, but this would be air handler 4 now, and the heat pump uses the same amount of watts from before, but that would be heat pump 4. So we borrow these numbers from up here, same numbers. I basically just copied this whole thing here and started just modifying it. There's no, and I could delete this to avoid confusion and say, and to show that all I used to calculate the size of the panel is this, or I could leave it. I'm gonna get the extra ones beyond the 1, just to clean up things a little bit. If I leave just the first one, it reminds me next time I copy this formula or this spreadsheet that, hey, don't forget the air handlers and the heat pumps, don't forget the water heaters, and if there's a kitchen and bar, don't forget to add that. This is going to change a little bit. It already changed from 108 to 222 because we have some air conditioning happening, right? There is, of course, water heater. That would be water heater 3 from the sheet. Water heater 3 right there. And you know what? If I just discovered a mistake in the earlier calculation. We actually do have 3 water heaters here, one in each bathroom and one in the kitchenette, right? So there'll be water heater 3. That number went out, but we still stayed under 400. I like my things to stay together. If I move this one here and that one there, something crazy is going to happen. So I'm just going to delete the kitchen and the bar. Delete that. I'm going to delete that, and I put water heater 3 right here, and then just type 3,000. That's going to change here a little bit. 391.11, but when we delete these guys, it goes back to 380. So water heater 2, and I had forgotten water heater 3 in the first building of specialty flooring. So actually, this is going to be water heater 4 now because there's 4 water heaters in the project. This was a copy. Let's delete that. That dropped a little bit. What else? So we know there's some air conditioning. We know the square footage of that. Let's find that out, of this little building here. That is a rectangular building, so it can use a rectangle to get the area. I think I have it in the mechanicals, but I can just find that out real quick. You decide what the quickest way for you at the time is, and go with it. But we want to try to work efficiently. So this is the area of that building 2, and the area is 4,000 square feet. So when we go here to the spreadsheet and panel 5, which is for building 2, if we enter the area at 4,000 square feet, this is going to drop because we're at 6,100. This will drop. Everything will drop. 4,000. I hit enter. And watch what happens here. So it'll drop to 168. What else is happening? So we have some air conditioning, we have a water heater, and we have an allowance of 5 watts per square foot, which I think is adequate. Adds it all across, and when it divides it by voltage here, and also divides it by phase, I get 168 amps. So basically what happens here is the following. The first, the showroom gets a 400 amp panel, and the rest of the offices get 200 amps. If I wanted to, and this is something you learn with experience, you could put a 125 amp panel here, but I want to give myself a little latitude here for bigger or more energy using spaces, like something that we use. If I put 125 in there, it's going to be tight, I guess is what I'm trying to say. So let's put 200 little fat there, and the same thing here. So that's where we are, and that's all the information we need to know for the electrical calculations. This is specialty flooring. I'm going to save the spreadsheet, and then I'm going to take this information and put it into my electrical schedules. So that first number, we calculate the watts, volt times amps. There's 109. Well, it changed actually because I added a water heater. It's 136,838. So let's fix that. 136 E001. It changed. 136 838. 838. Then we'll go over here and see calculated amps is 380 at 125%. And then that means the panel size is 400, which stays the same. And that's information at the bottom of our schedule. That number right here, 400 amps, will correspond with the size of the panel. So this is information on the panel. It's 100 volts and 208 volts at 3-phase. 3-phase requires 4 wires. Single phase requires 3 wires. going to be surface mounted, 400 amps. And this is a number that we'll calculate. And maybe we'll get into that later. But that's our panel schedule. That's what it looks like. For panel 5, it'll be different. I'm going to erase this because it's easier just to copy this and modify it. So panel 5 is 122 8-volt, 3-phase 4-wire, same. It's surface mounted, but it's only 200 amps. So all I have to change is the 400 to 200, and this changes a little bit. That was panel 5. We scroll down, we'll see panel 5 is 60, 330, and 168. 330 and 168 is the calculated amps at 125%. And I said that we're going to make that a 200 amp panel. Then we're going to create a panel of P3, P2, P3, P4. So panels, and this is a generic schedule. P2, P3, P4. It's still going to be 108, 122 8-volt, 3-phase 4-wire. That doesn't change. It's still going to be surface mounted. It's still going to be 200 amps. There'll be none of that here because we don't know what's happening. So we'll change all of this to dashes. We'll change all of these to spaces. There's going to be a panel in there. There's not going to be anything connected to it. And I'm going to populate every cell. So I'm going to copy this one down to there. Same thing here. I'm going to do this one in advance. Make a copy, bring the line. So what I said was all of these were going to be dashes, as in blanks. And this are going to be just a space in the panel. Be careful not to pick up the wrong thing and make that change. So that will be space. And this changes a little bit from, I'm going to delete these notes because we can't have GFIs or photocells if we don't know what's connected to it. And these numbers will change a little bit. Let's see what they are. 39,108. 39,108. 200 amps, that stay the same. So here we are. We size all the panels. And when we look at our panel schedule, we'll have panel P1. And then let's insert the other panels here. I'm going to copy this one. I'm going to stretch it out to where I can see panels P2, P3, P4, and P5. I'm going to move that there to this corner, and then I move it down so it lines up. And it's not on top of each other. Then I'm going to shrink the viewport. Let's make it perpendicular to this. And I'm going to shrink the viewport from the other side perpendicular to this. So we have panel P1, P2, P3, P4. Let's bring in panel P5. So I'm going to copy this viewport. I'm going to stretch it out until I can see panel P5, which I know is to the left. I'm going to move from this corner to this corner, and then I'll move it down this distance. So the distance is uniform. That distance right there is the same as that. I'll take that, move it perpendicular. That really won't matter too much because those will be invisible when we try to plot. So now we have panel P1, P2, P3, P4, and panel P5. And when we try to print the sheet, the lines won't show up. The green lines here won't show up because they're invisible in a layer called def points that doesn't plot. But here we are. So we were able to get this with the spreadsheet, these numbers right here, for all 3 panels, or for all 5 panels. We populate this information. In a separate video, we'll figure out how to do this right here. Where that information comes from. And then, of course, the lighting schedule. And this is not quite accurate yet, but fixture A will enter the model number and the manufacturer, the wattage, and a description of it. And we'll do that in a separate video as well. This concludes part 2 of video number 1 of the electrical series.